This content is produced by Pass the CSLB, an independent audio-first study companion for busy California B General candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. The most important field decision in quality insulation installation is deciding when a wall is allowed to disappear. If the air barrier, cavity fit, and required verification are not complete. While the work is visible, drywall can turn a correctable detail into concealed work and a scheduling problem. A wall can contain the specified insulation and still miss the quality standard because the batt has gaps, has been crushed, or has no continuous air boundary around it. I treat required verification as a before cover hold point. That phrase is worth remembering. Before the board goes up, the contractor needs to know what must remain visible, who must verify it, and which record closes the verification step. Suppose a drywall crew is released because the insulation looks finished from the hallway. If the required rater has not inspected the concealed conditions, photographs and assurances do not automatically replace the prescribed field verification. Board may have to come back down, or another approved resolution may be required. The immediate mistake is not merely poor insulation, it is losing access to the evidence. Based on the published CSLB study outline, insulation, acoustical work, and weatherproofing fall within testable core trade material. Quality insulation installation turns that broad subject into a general B supervision problem. Coordinate trades, recognize visible defects, preserve inspection access, and avoid claiming expertise and energy modeling that belongs elsewhere. When quality insulation installation is required, the independent verifier is a certified home energy rating system rater. The ordinary city or county building inspection does not become the quality insulation installation verification simply because both inspections concern work in the same wall. I keep those roles separate. The local building authority has its inspection responsibilities, while the certified rater performs the prescribed energy, compliance verification, and completes the verification record. The paperwork follows the physical work, but the contractor should read it before the work starts. The Certificate of Compliance, commonly called CF1R, establishes the design requirements and indicates whether quality insulation installation is triggered for the project. The Certificate of Installation, commonly called CF2R, is signed by the installing contractor or by the General B contractor when acting as the installer to certify the installation. The Certificate of Verification, commonly called CF3R, is completed by the certified rater after passing verification. I put those three records in order because their names sound similar while their jobs are different. Design comes first, installation follows, and independent verification closes the sequence. The installation certificate is not a substitute for the verification certificate. That distinction protects the schedule because it tells the contractor exactly whose action is still outstanding. My practical move is to review the compliance documents early, confirm whether the quality requirement applies, identify the required inspection points, and get the rater into the schedule before insulation mobilizes. I am not performing an energy model in that field check. I am translating the approved compliance path into trade sequence, visible quality, and a clear hold point before concealment. The physical heart of this lesson is the six-sided enclosure. A typical vertical cavity has a top boundary, a bottom boundary, a back boundary, a front boundary, and two side boundaries formed by the adjacent studs. That makes 6 surfaces. Insulation needs the intended enclosure around it so outside or unconditioned air cannot freely bypass the thermal material. Looking at the reference table, notice that the 2 studs count as 2 separate sides. The back may be sheathing or another approved continuous barrier. The front is commonly the interior finish, such as drywall. Because that front surface is not yet installed during the open wall inspection, the rater can examine the other visible boundaries and the insulation fit before the front is concealed. I use a jacket comparison because it keeps two different jobs straight. Fibrous insulation is like a thick sweater. It slows heat flow by holding many small pockets of air, but it is porous. A continuous air barrier is like the windbreaker over the sweater. It controls moving air. A thicker sweater does not become a windbreaker just because more material is stuffed into it. In the same way, fiberglass batt is thermal insulation, and it is not a rigid draft stop. That distinction becomes important at drop ceilings, chases, knee walls, and other concealed transitions. A hard cover or draft stop made from a suitable solid material keeps insulation in place and blocks the air path. The joints and penetrations in the building envelope must be caulked and gasketed or otherwise sealed to limit air movement. Filling an open chase with loose pieces of fiberglass does not create the required solid boundary. Imagine a contractor managing a vertical plumbing chase that connects an unconditioned lower space to an unconditioned attic. If the chase boundaries and pipe penetrations are left open, air has a route around the insulated assemblies. The corrective work is not to pack more porous insulation into the opening. The field issue is the missing rigid boundary and its unsealed penetrations. Catching that before the surrounding finishes arrive keeps a barrier detail from becoming demolition and rework. Once the enclosure is ready, I look at the batt itself. In an unobstructed cavity, the material should completely fill the intended space without avoidable gaps or voids. It should contact the framing at the edges and extend from top to bottom. A narrow strip left open at a stud is not a harmless cosmetic defect. It is an uninsulated path through the cavity. The comparison table separates the common defects from the field-ready condition. I start with 3 questions. Is the full cavity filled? Has the batt kept its intended loft? Has every wire, pipe, or unusual framing condition been fitted without creating a void on one side? Compression matters because fibrous insulation depends on trapped air within its loft. Crushing the material pushes fibers closer together and removes part of that trapped air structure, so the installed performance no longer matches the full loft condition. The allowed 30% figure is not general permission to compress every batt. It is a maximum exception around plumbing, vents, and non-standard framing. In a standard unobstructed bay, the installation should retain its full nominal loft. Wires and pipes create the classic temptation to force the whole batt to one side. If the batt goes entirely behind a pipe, a void can remain in front. If it goes entirely in front, the material can be crushed behind it. The quality method is delamination, which simply means splitting the batt through its thickness so part fits behind the obstruction and part fits in front. The obstruction becomes surrounded instead of becoming the edge of a void. I do not need a complicated mnemonic for that. I picture a sandwich. The pipe or wire belongs between insulation layers, not outside the entire batt. That picture leads directly to the field check. Trace the obstruction across the bay and confirm that the insulation continues on both sides of it. Suppose an installer reaches a crowded plumbing area and compresses a batt to roughly half its nominal thickness. Even though compression is allowed in certain constrained locations, half thickness is beyond the stated 30% maximum. The contractor should stop, refit the material, and restore a compliant condition while the cavity is open. Waiting for the rater to identify the same visible defect only consumes schedule. Several special locations deserve a deliberate pause during the walk. At a tub or another large fixture placed against an exterior wall, the sequence must preserve the required cavity boundary. If the fixture blocks later access, the suitable, rigid barrier and related insulation detail need to be completed at the proper stage rather than improvised from above after the fixture is set. Recessed luminaires in an insulated area create another coordination point. A fixture that will be covered by insulation must be rated for insulation contact and rated airtight. Leaving an insulation gap around a fixture that lacks those ratings breaks the continuity required by the quality installation. The source-backed correction is to replace the fixture with a compliant insulation contact and airtight unit before covering it with insulation. Loose fill insulation is checked differently from a batt. The rater verifies installed depth and density in at least 6 random locations and compares the installation with the manufacturer's coverage chart. That means a smooth-looking surface is not enough. The contractor needs the specified depth, the required density, and access for representative checks. For above-grade wood-framed walls separating conditioned from unconditioned space, the 2025 California Energy Code source identifies an assembly U factor of 0.095 for 2 by 4 framing, commonly achieved prescriptively with R15 cavity insulation. For 2 by 6 framing, it identifies an assembly U factor of 0.069, commonly associated with R21 cavity insulation. I treat those as compliance document checkpoints, not permission to swap materials by memory. The approved project documents and current requirements control the actual build. California also requires insulating materials to carry the applicable state certification. That makes procurement part of quality control. A product that appears thermally similar is not automatically acceptable when the project requires certified material and documented performance. The clean sequence is easier to manage than the repair sequence. Framing must leave access for the required barrier details. Electrical, plumbing, and mechanical rough work creates the penetrations and obstructions that must be sealed and fitted. Air sealing and rigid draft stop work must be complete where required. The insulation installer then fills and fits the cavities. The certified rater receives the required access and documentation. Drywall follows only after the applicable verification. Hold point has been released. The exact inspection arrangement can depend on the approved compliance path and project conditions, so I do not invent a universal number of site visits. I confirm the required points with the project documents and the registered rater. What does not change is the need to keep the relevant work visible until its prescribed visual verification is complete. Before calling for verification, I walk the work in the same order that defects become expensive. I start with boundaries at chases, drop ceilings, knee walls, and blocked areas. I check sealed joints and penetrations. I scan unobstructed bays for full fill and loft. I follow wires and pipes to see whether batts are split around them. I check constrained areas against the compression limit. I confirm fixture ratings and loose fill access. Finally, I verify that the correct installation record is ready and that the drywall crew understands the hold. Consider a hypothetical project where the board delivery is early and the drywall crew has an opening in its schedule. The fastest looking decision is to let the crew close one floor while the rater is still booked for the following day. That decision trades a small schedule gain for concealed conditions the rater was supposed to see. If the work cannot be verified as prescribed, reopening walls becomes possible. The disciplined decision is to protect the hold point even when another trade is standing ready. There are 2 scope boundaries I want to keep clean. First, under the cited 2025 addition provision, an addition to an existing building that is 700 square feet or less is prescriptively exempt from the specific quality insulation installation requirement. That does not erase other energy requirements, material rules, or ordinary inspections. It means the contractor must identify the applicable compliance path instead of adding or removing verification costs by assumption. Second, field supervision is not energy modeling. A General B contractor should recognize the approved assembly, coordinate the installation, catch visible quality problems, and preserve the documentation path. When a proposed substitution changes the assembly or the compliance analysis, the correct move is to return to the responsible design or energy compliance professional and the authority having jurisdiction. Worker protection is a separate obligation from thermal performance. Spray polyurethane foam can expose workers to hazardous chemicals, including isocyanates. When an employer uses tight-fitting respirators for hazardous insulation work, California respiratory protection rules require a written, worksite-specific program. The program includes administration, medical evaluation before fit testing, and appropriate respirator selection and use. Buying masks at a store does not create that program. For the General B contractor, the practical supervision point is to verify the specialty contractor safety program before mobilization, rather than discovering a missing program during application. I do not select cartridges or conduct medical evaluations unless I am qualified and responsible for that program. I confirm that the responsible employer has the required system in place and that site coordination does not expose other workers to the operation. I remember this entire lesson with one short field sentence. Before board, verify the boundary, the batt, and the paperwork. Boundary means the continuous air control surfaces and sealed penetrations. Batt means complete fill, full loft, and proper fitting around obstructions. Paperwork means the compliance path, the installation certificate, the certified rater's verification, and a documented release of the hold point. If you can apply that sentence, you can walk an open wall with purpose. You are not judging the work by color, brand familiarity, or whether the room looks full of insulation. You are checking whether the installed condition preserves the assembly that the compliance documents describe, and whether the independent verifier can still see the evidence. I made an audio practice quiz for this specific episode, so you can test these exact field decisions. It is audio-based. I read each question aloud, and you answer by tapping, which works well when you are studying while driving, working, or otherwise on the go. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. If anything in this lesson is unclear, comment below with your question. I read those questions and they help me understand where a careful contractor needs a cleaner explanation. Subscribe so I can help you stay on track through every episode until you get your license. I know you are fitting this study time around real work and real responsibilities, and I am rooting for you all the way to that license.